Hello everyone. Now I am going to explain the brick problem. What essentially is the brick problem? We are laying bricks. There are two kinds of bricks. One is a big brick and another one is a short brick, small brick, let's say. And there are 8 empty spots here. We can number them. These are adjacent brick spots. So you can cover each spot with one small brick, or you can cover 2 spots with one big brick, and one big brick is 2 times the size of small brick, and one small brick is half the times of one big brick. All the bricks are identical. Now, given this to be the case, now we have to figure out how do we solve this. One way to solve this is by just having all small bricks. There'll be 8 small bricks and you can keep them adjacently. That's one way. Or you can have 4 big bricks. That's another way. Third way is you have a big brick, small brick, big brick, small brick, and a big brick, which covers 8 spots. Now, these are the 3 ways that I would describe. Now, the question here is, how many ways are there by which you can arrange these bricks? And these ways are as described previously. So we have shown 3 ways right here, and we have to figure out how many such ways exist. Now, broadly, what we are trying to say is how many cases are there. So all small is one case, all big is another case, and then you introduce one big brick along with 6 small bricks. You can have another case wherein you have 2 big bricks and 4 small bricks. You can have another case wherein you have 3 big bricks and 2 small bricks. Right? These are all the cases. I mean, there cannot be any other case apart from this. So we know the 2 cases properly. We need to figure out what are the ways by which one big brick and 6 small bricks can be arranged. And it's quite obvious by just looking at it. If you just do trial and error, you can probably figure out there are 8 spots. You move half a spot of a big brick every single time. So there are about 7 ways. You can do it in another way, wherein you can consider them to be like adjacent letters in an alphabet. And depending on the number of spaces, if all of them are unique, you just take a factorial. If 8 characters are unique, the number of ways by which you can arrange them is essentially 8 factorial. Since there are about 7 elements here and 6 of them are repeated, it's 7 factorial upon 6 factorial. And the answer is 7. Now we take the second case wherein you have 2 big bricks and 4 small bricks. It's essentially 6 different elements here. 4 of them are repeated, 2 of them are repeated in one kind. So it's 6 factorial upon 2 factorial into 4 factorial. That gives you 15. Another case is you have 3 big bricks and 2 small bricks. So it's again 5 elements, 5 factorial upon 3 factorial into 2 factorial. That gives you 10. So if you add them up, it'll be 34. Now the interesting point to notice about the number 34, we'll just write T8 as 34 because there were 8 spots like this and we got 34 different ways. Just write them as T8 is equal to 34. And I'll write another sequence of numbers here, which might be familiar to a lot of people. This is a Fibonacci series where each number is the sum of previous two numbers. One is the first number, and another one is the second number. And from T2 onwards, everything is a sum of previous two digits. So here T8 is a Fibonacci number for the 8th spot, right? That's the 8th Fibonacci number. Now what you have to understand is this is true for all such cases. So assume that there are 6 empty spots. T6 would be the answer according to this theory. Let's verify that. So how many cases, if there are 6 empty spots, the number of ways you can arrange 6 empty spots is 6 small, 3 big, 1 big and 4 small, 2 big and 2 small. And that's pretty much it. That's one way. This is again 5 factorial upon 4 factorial, and that's 5. And this is 4 factorial upon 2 factorial into 2 factorial. That is 6. So if you add all this up, you'll essentially get 13, which happens to be T6. You know, this essentially is the origin of Fibonacci numbers. How that is the case is something that you have to figure out on your own.